To Unit 1, Notes 5. So today we're going to be talking a little bit about linear measure. So let's take a look. So when we're talking about linear measurement, we're talking about segments. Okay, so first of all, we need to define a segment. We've learned about lines, we learned about planes, we learned about points. Okay, so now we're going to talk about line segments. So a segment is a part of a line that is with endpoints. So the biggest thing you need to know about a segment is that it ends. Okay, and the segment itself is named by its endpoints. So let's go ahead and let's take a look at that. So we're going to have a segment. So the thing about the segment is we don't have arrows at the end. We actually have end points, so points that end the segment. So say M and N. Okay, so now we want to name this segment, which is MN. And what we do to name a segment is we just put a line over it. Now before, when we were naming lines, we would put arrows at the end of the lines. But this time we're not going to do that because the line doesn't continue. This is how we show that it is a line segment. So let's take a look at the next question. Can you find the length of a line? Yes or no, and then explain. Well, no, we can't. No, we can't find the length of the line. And the reason is that it extends indefinitely. Okay, so a line is going to continue on forever in both directions. So because it's continuing on in both directions, we can't measure it because it's going on and on and on and on and on. The fact of the matter is you can't measure something that doesn't end. So let's take a look at the next one. Can you find the length of a line segment? Explain. Yes, we can. And the reason we can is because it starts and ends. Okay, because it starts and ends. So because it has endpoints, we can do that. It starts and ends. Okay? All right, let's go ahead and let's keep moving. Let's take a look at number 1. So we want to find the length of A and B. All right, so we're going to kind of make an estimate. So there's a ruler there. So I see, first of all, that B goes past 3, but doesn't quite get to 4. So I know that the whole number is going to be 3. Now I want to see, okay, how far does it go between 3 or 4? So this is where, for this one, because there's no lines in between, I just need to make an estimate. So to me, it looks like it goes 3/4 of the way to 4. So I'm going to put that, 3/4 of the way to 4. And that's going to be labeled in centimeters. So let's take a look at B. So for B, we want to measure that out. Okay, so we're looking, and I see first of all that it's again between 3 or 4. So my whole number is going to be 3. Now I want to count the little lines in between. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 lines in between 3 or 4. So the bottom of my fraction is going to be 10. Now let's count how many lines it takes for us to get to that point B. We have 1, 2, 3, 4, 5, 6, 7. So 7. So we have 3 and 7/10 because we used 7 of the 10 lines between 3 and 4. Again, we want to make sure that's centimeters. You guys can go ahead and cross off B and D. We're not going to do those on this video. Let's take a look at number 2. So for number 2, we want to measure this out. So again, I notice that B is in between 3 and 4. So I'm going to put 3. And then I want to count. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the bottom of my fraction is 10. So now I want to figure out how far my B is going over. It's going 1, 2, 3, 4, 5, 6, 7, 8. So the B is using 8 of the 10 lines. Now this is pretty, but we want to make sure that we have fully reduced fractions. So we need to go ahead and reduce that fraction. So 8 and 10 are both divisible by 4. So that's going to give us 4/5. Okay, so 3 and 4/5 would be our answer. We want to make sure we label it. Our label is centimeters. Okay, let's take a look at number 3. So number 3 says to find the length of RS. Okay, so first thing I notice is that R is between 6 and 7. So I know that RS for sure has a whole number of 6. So now I want to count how many total are between 6 and 7. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's not always 10. When you're using centimeters, it typically is. And that's what we're doing on the top here. We're using centimeters, so each of those represents a centimeter. So the bottom of our fraction is 10. So now we want to figure out how many of those S uses. So we're going 1, 2, 3, 4, 5, 6. So S hits at the 6th line. So we're going to do that. Last thing we want to do is reduce that fraction so we can keep 6 the same. 6 and 10 are both divisible by 2, so that gives us 3 over 5. And then we want to make sure we label it, so we have 6 3/5 centimeters. Okay, moving on. Let's take a look at number 4. So we want to find the length of RS. So now we're moving it to inches. So our ruler is in inches. So I noticed that the S lands between 1 and 2. So my whole number is going to be 1. And then I noticed that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 little dashes between 1 and 2. So my fraction is going to be out of 16. So let's count how many we use. We have 1, 2, 3, 4, 5. So the S hits at the 5th dash. So we have 1 5/16. And we want to label that inches. Make sure that none of our fractions can be reduced, and they can't. So 1 5/16 is our final answer. Okay, so I want you guys to go ahead and try to find TV on your own right here. So that's using inches. So what you're going to do is see what whole numbers it lands between, count how many ticks are in between, and then see which tick it lands on. If you need help, definitely let me know. Okay, let's talk about betweenness of points. Okay, so it kind of makes sense. It seems pretty logical. So basically what a betweenness means is looking at this diagram, we can state that S is between R and T. S is between R and T. Okay, that's all that we need to know to use what we're going to do next. Okay, so let's go ahead and move forward, and let's take a look at how we're going to use this betweenness idea. Okay, so it wants us to find the length of XZ. So it wants us to find the length of this whole line. Okay, when we know that XY is going to be 4.5 and YZ is going to be 3.2. So to find the length of the whole thing, we're just going to add those two together. So 4.5 plus 3.2. And that's going to give us 7.7 centimeters. This is good. Okay, so let's go ahead. We're going to skip number 7 and let's move on to number 8. So it says here to find X and ST if T is between S and U. ST is equal to 7X, SU is equal to 45, and TU is equal to 5X minus 3. So the best thing to do for these is to start by drawing a picture. Now we're talking about segments here. So we want to find ST. So T is between S and U. So T is going to go in the center. It doesn't necessarily have to be in the exact middle. You could have put T way over there if you wanted to. Okay, so let's go ahead. And so we know that ST, this length right here, is going to be 7X. Then we know that SU, so the length of this whole entire thing, is going to be 45. And then we know that the length of TU is going to be 5X minus 3. So what we want to do right now is we know that between ST and TU, we can make all of SU. So that means that this plus this has to be equal to that. So we have 7X plus 5X minus 3 is equal to 45. Now we can go ahead and solve for X. First thing I want to do is combine like terms. So 7X plus, 7X plus 5X gives me 12X minus 3 is equal to 45. So then we're going to add 3 to both sides. Okay, so next thing we want to do, hold on a second. Next thing we want to do is we want to go ahead and add these together. So we have 12X is equal to 48. So we're going to divide both sides by 12, and we get that X is equal to 4. So let's go ahead and set up number 9, and then I'm going to have you do that on your own. So we have XY, and we know that Y is between X and Z. So for x and y, we have 3a. For xz all the way across, we have 5a minus 4. And for yz, we have 14. Okay, so to set this up, we know that 3a plus 14 has to be equal to 5a minus 4. So go ahead and solve that for a for me. Last but not least, let's take a look at congruent segments. So if we're looking at these, you notice that they have the same measure. If two lines have the same measure, then they are congruent. So we can say that segment MN, and we're going to put the line over it because that represents a segment, is congruent to QP. So this is the symbol for congruent. So in your little box on your note sheet, you want to make that symbol. That means congruent. So we're talking about geometric shapes being equal to each other. We use the congruency symbol. So if anything is congruent, then it has the same measure. So thank you for listening, and go ahead and show me your completed note sheet when you're done.